Welcome back. Today we're going to be doing the related rates question involving a conical tank, so let's dive in. A conical tank, vertex down, has a height of 10 meters and a radius of 4 meters. If water flows in at 3 cubic meters a minute, how fast is the water level rising when the depth is 5 meters? And as you can see, we have four choices here, so we will narrow it down and figure out which one it is. So first thing I'm going to do is I'm actually going to write down my givens, and I'm also going to draw a diagram of this conical tank with the vertex down that we're apparently going to fill up with water. Okay, so first things first, I know that dV over dt is equal to 3 because in the question they told us that the water flows in at this rate. And so the rate at which the volume is changing with respect to the time would be 3. The other thing I want to note is that the volume of a cone in general is 1/3 pi r squared h. So that's also a crucial thing we need to know. And now I'm actually going to go ahead and draw my cone. So here's my cone. Let's try a bit harder here. Okay, that's not terrible. That is good enough. Okay, so they said that the radius was 4 meters and that the height was 10 meters. And there we go. The other thing that basically what's happening here, I want to make sure it's clear what's happening, is water's flowing in. So it's going to, of course, the height's going to be increasing really quickly at first, and then it's going to slow down, right? Because it's the same amount of volume at once, but of course, the higher we get into this cone, the more volume, right? And so what they're asking here is how fast is the water level, so like the height essentially of this rising, or like how fast is the depth rising when the depth is at the 5 meter mark, so halfway between. So essentially, what they're asking is when our height is here at the 5 meter mark, then how fast is it, or not how fast is it coming in, because that would just be the 3 cubic meters a minute, but how fast is it like rising up, right? What's the rate of change with respect to the actual height, or the depth, I should say? Because of course the height's always 10 meters, but we're really wanting the depth here. We will be using height as depth when we're talking about the volume though. Okay, so the next thing I'm going to do is I'm going to use similar triangles in order to relate R and H. Notice that we have this triangle right here that has legs of 10 and 4, and that means this triangle with a height of 5, right, or depth of 5, must be a similar triangle. So if this is 5 meters, then the other one has to be 2 meters, right? Because it has to be half of whatever 4 is, since 10 is half of whatever 5 is. Or in other words, to find this value, we could say that 10 over 5 must be equal to 4 over x, right? 4 over this one, essentially, because they're similar triangles. And then if we solve for x, we do indeed get that x must be equal to 2. We get 5 times 4, which is 20, divided by 10, which is 2. And so we do get 2. So we can essentially use similar triangles to figure that one out. We can also use similar triangles to relate R and H. We can say that R over H is equal to 2 over 5, which means that R is equal to 2/5 times H. And now that we've related R and H, I'm going to plug that back in actually into the volume equation. So we're going to get that the volume is equal to 1/3 pi, and then instead of R squared, I'm going to sub in 2 over 5H squared times H. So then that's going to be 1/3 pi times, let's see, 2 squared is 4, 5 squared is 25, so 4 over 25, H squared times H. Then if I simplify that even more, I will get 4 pi over 75 times H cubed. Okay, cool. So now we have a volume equation just with respect to the height, and that's exactly what we need to get in order to do the next step. Okay, because the next thing we're going to do is we're going to take the derivative on both sides. We're going to do dv over dt, which we already know what that is. We already know that's 3, but we'll plug that in pretty soon. So dv over dt, the change in volume with respect to time, must be equal to 4 pi over 75 times h cubed. And then we have dh over dt, and that's what we're trying to figure out. We want to know how much the height changes with respect to the time. So that's what we're trying to figure out. In this case, we know that dv over dt is equal to 3, since that was given in the question. And in this case, we're wondering at the depth of 5. So in this case, instead of h being 10, even though the height of the full conical tank is indeed 10, the height we're actually going to sub in here is going to be 5, because we want to know, okay, what is this rate of change when our height is only 5, when we're only filled up to this point, essentially. And so that's why height is going to be 5 instead of 10. And that's probably the most common mistake I see with these questions, is we assume, oh, we plug in 10 because that's our height. Well, no, we plug in the height that is correct to the equation, or to the to what the question is wanting from us. Okay, so now I'm going to plug in those numbers. I'm going to get that 3 is equal to 4 pi over 75, and then I need to take my derivative. Actually, I forgot to do that. Instead of h cubed, it should be 3h squared. My apologies. 3h squared. So that's going to be 3 times 5 squared dh over dt, which that's what we have to simplify here. So let's see. Actually, this works out really nice, because 3 times 5 squared is just 3 times 25, which is 75. So that can cancel out with this 75. And then if I divide both sides by 4 pi, I get that dh over dt is equal to 3 over 4 pi. And there we go. So therefore, the final answer is that at the point when the depth is 5, the rate of change is 3 over 4 pi meters per minute. So that's how fast the water level itself is rising, right? How fast the height or the depth is changing of where the water's at when we're at the 5 meter mark. Now, of course, if we calculated this for a different mark, for a higher mark, it would be slower, right? It would be less than this. Or if we did it for a lower down, like before 5 meters, it would be more. It would be filling up faster because there's less volume here, right? But yeah, so that is everything for that question. I know this is quite a very classic question for calculus. If you do have any questions about it, though, feel free to leave those down in the comment section, and I'll see you for the next one.